evening, everybody. So, I'm going to go ahead and redo the solving inequalities lecture that I did earlier today. And if you didn't get some of it, or you'd like to see a review of it, I'm going to do that real quick. So, we start off with just understanding what the inequality symbols look like. So we have two sets here. We have a set that looks like this. This is one of the sets. And the other set looks like this, with the only difference between the two sets being this right here. But it's a big difference. Without the equal to sign at the bottom, without that straight line right there, it changes everything. This is saying that it's okay for the answer to be less than or equal to. And this is okay to be greater than or equal to. This one, it's not allowed to be less than. It has to be, not allowed to be equal to. It has to be the less than or greater than. So when we go to do these number lines, for this one, we're going to use a donut, meaning a circle, an unfilled in circle. I'm going to call that a donut. This one, we're going to be calling a dot because it's completely filled in. So donuts do not have the line underneath. Dots do have the line. So these are donuts, and these are dots. Okay? So it's super important that you make the connection between the equal to sign and the dot. Lastly, what I'd like to talk about is how do you remember if it's the less than symbol or the greater than symbol. And I mentioned today in class that the less than symbol makes an L. So this symbol makes the L for less than. So that's the less than symbol, that's the greater than symbol. So if you can remember that the L is the less than, then the other one is the greater than. Okay, let's start looking at some problems here. And the first thing I want to look at is we have our dividing point. Now what I suggest that you guys do today is to always set up your inequality the exact same way. Once you get to the number line, to always set it up the exact same way. So how we're going to do that is underneath my dividing point, I'm going to write the number, which is 5. Underneath the arrow, I'm going to write my variable. Doesn't matter what your variable is, I'm going to put X. If you do those two things, then this is always the same. The symbol is always the same, and that symbol is less than. So 5 is less than X, and that's my answer. 5 is less than X. If you want to write it with the X on the left-hand side, that's fine. Just switch the symbol, so X is greater than 5. Either one works. Okay, here we go. I'm going to put underneath my dividing point, I'm going to put my -2. Underneath my arrow, I'm going to put X. And if I do those two things, I always use the less than symbol. So my answer is -2 is less than X. If you want to write it so X is first, it would be X is greater than -2. The next one, underneath my dividing point, I write -17. Under my arrow, I write X. If I do those two things, it doesn't matter where my X is, I always use the less than symbol. So for that problem, X is less than -17. And for the last one here, underneath my dividing point, I'm going to write 30. Underneath my arrow, I write X. I always use the less than symbol. I need to go back and check this one actually. That one was equal to. I missed that. Equal to, so it should be less than or equal to. That also is an equal to, so it should be an equal to underneath there. That was not an equal to. That was a donut, so I don't have to worry about that one. Down here is also a donut, so I don't have to worry about it. So X is less than 30. Make sure you did catch that this one should be equal to, and this one should be equal to as well. Okay, so once we get it to the number line, it should be relatively easy. Underneath your dividing point, put your number. Under your arrow, you put your X. If you do those two things, you always use the less than symbol, which is right there. Okay, now let's get to the number line part. So starting from the very beginning, we have two problems here. We have this problem and that problem. And this one we've been doing for quite a while. It's solving one-step equation. Here's my cups and beans and beans. So we have my cups, beans, and beans. Now, to get my cups by themselves, I need to subtract 5 from both sides. I'm left with x equals 4. No big deal there. We've done that forever. Over here, it's an inequality, which means I have more than one answer. For this one, I have exactly one answer. X has to be equal to 4, nothing else. But for this problem, there's lots of answers that x could be that will make this true. X could be 100. 100 plus 5 is bigger than 9. So there's lots of answers. So we want to find all the answers and we want to represent all the answers. So to do that, we're going to do our first step, our same first step every single time. And that first step is this. X plus 5. And see if you can figure out what it is we need to do. And what we did was, we changed the inequality to an equal sign. So now I have this equation, which is exactly like that one. X plus 5 equals 9. That's our first step always. Change the inequality to an equal sign. Then, I need to get x by itself. I need to solve for x. So I'm going to subtract 5 from both sides, just like we did before. So x equals 4. What I just found is the dividing point. I just found the dividing point. The dividing point is the number that separates correct answers from incorrect answers. So as I go to do my number line now, here's my number line, and right in the middle I put 0. So what I'm going to do is I'm going to put my dividing point on the correct side of 0. This is positive 4. Which side are the positives on? Are the positives on the left side or positive on the right side? Well, of course, positive numbers are always to the right, so I put 4 like that. Then I need to put in my dot or donut. So after I plot my dividing point, I plot my dot or donut. I come back and look here at my original inequality, and I see I don't have an equal sign underneath there. Since I don't have an equal sign, that means it's going to be a donut like these. So above this, I put a donut, just like that. And then I need to figure out which way to move my arrow, or which way for my arrow to go. To do that, I'm going to do a little sum problem. So what I do is I'm going to take 0 and plug it in there. So I say I have 0 plus 5 is greater than 9. Well, 0 plus 5, of course, is just 5. That's why I like to use zeros, because it's easy to do. 5 is greater than 9, that is false. Since 0 is false, that means this 0 is false. And what we figured out is our dividing point divides true answers from false answers. So if this side is false, that means everything on this side is false. All of these numbers over here are false. If all of these numbers are false, that means these numbers are true. Okay, so one side is going to be false, the opposite side is going to be true. And now I'm ready to solve my equation. So, just like we did over here, underneath my dividing point, I'm going to write my number, which is 4. Underneath my arrow, I'm going to write my variable. And if I do that, I always use the less than symbol. I come back up here and see it's not equal to, so it's not equal to. So 4 is less than x. If you want to switch it around, you can. Just make sure you switch the symbol. So x is greater than 4. Okay? How about this one? Same thing. My first step is I'm going to turn it into an equality, an equation. Minus 3 equals negative 7. And then I'm going to solve for x. Do the opposite operation. Add 3 to both sides. I end up with x equals. Now, over here, you probably want to do a diagram. 2 negatives, 1 positive, circle 1 of each. That gives me negative 4, because I need to subtract there. This is my dividing point. Okay, there's my dividing point right there. Now I'm going to do my number line. 0 in the middle. And it tells me to put this at negative 4. The left side is negative, so I put it right like that. And then I come up and look here and see, I'm going to do dot or donut now. I see that symbol has an equal to sign. The equal to sign means dot, so I'm going to go ahead and put my dot in. The dot goes right above the negative 4 there. And now I got to figure out which way to put my arrow. So I do that by doing a subproblem. So I come back to my original equation and I say 0 minus 3 is less than or equal to negative 7. Negative 3 is less than or equal to negative 7. And that's true. Negative 3, excuse me, no it's not. Negative 3 is not less than negative 7. So this is false, which means everything is false. So that means the line goes in that direction. So you go, then what you're going to do is you're going to, then we're going to put our actual answer in. So right below the dividing point, I put negative 4. Below the arrow, I put x. And if I do that, I always use the less than symbol. Because it was equal to, it's less than or equal to. And this is my actual answer right here. That's my answer, and that is my answer. Okay, so there's a couple of examples that show this, all the steps of the process. It's a lot of steps. There are some shortcuts that can be made, which I do not encourage you to do. And we'll see some examples of how they might not work quite as well. All right, last two problems right here. So again, first thing that we're going to do is we're going to rewrite it so that it has an equals to sign. So 2x equals negative 12. And for this one, we need to do the opposite operation, find our dividing point. So we're going to, here we're multiplying. The opposite of multiplication is division. So I divide both sides by 2. That simplifies out, and I'm left with x equals. And then these signs are different. When the signs are different, the answer is negative. And that's negative 6. And so that's now my dividing point. Okay, so I just found my dividing point. So now I can plot my graph. There's 0. The negative 6 is going to be on the left-hand side. So I put my negative 6 like that. I come back, look here. I have a equal to sign. So that means I'm going to use the dot instead of the donut. So I'm using the dot. Now I need to figure out which way my arrow is going to go. I plug in and say 2 times 0 is greater than negative 12. 0 is greater than or equal to negative 12. That is true. That means that the 0 is true, and the arrow always goes towards the true side. So it goes like that. Now I'm ready to do my answer. Below my dividing point is negative 6. Below my arrow is x, and it is the less than symbol. So negative 6 is less than x. If you wanted to say x is greater than, or equal to negative 6 is the answer. You don't have to do this for my class. You can if you want to. If you switch the order, make sure you flip that sign. All right, last one here. We're going to do our first step, which is to change it into an equal sign. 5 equals x minus 7. Then we're going to solve for x. Do the opposite operation. Add 7. Add 7. 12 is equal to x. I just found my dividing point. So now I can plot this on a graph. Here it's taller. That's 0. 12 is positive, so that is going to be on the right-hand side. So there's 12. And then need to put a dot or a donut on there. And I look right here, see there's no equal to signs. That means it's going to be a donut. And then I need to test and find out which direction to put my arrow. So I'm going to plug in my 0. So 5 is greater than 0 minus 7. 5 is greater than negative 7. That is true. So the 0 is true. And the arrow always goes towards the true side, so it goes like that. And my final answer here is, that gives me 12. This is x and less than, so x is less than 12. So these are all my solutions here, doing these problems. It's several steps. None of them are particularly difficult. Just make sure that you always put the x under the arrow, the dividing point under the dot or the donut, and if you do that, you always use the less than symbol. Okay, hopefully that clears it up from today's notes, and I'll see you tomorrow.